What's up, Toby? How you doing?
Good. How you doing?
Doing fine. Doing fine. So, yeah, for people listening, I actually have a cold right now or something like that. So my voice is a couple octaves lower, um, like very white. That explains why. But enough about me. Toby, I can't remember how you came on my radar, but you're doing some cool stuff. See a lot of people talking about SQL Mesh, so figured it'd be a good chance for us to talk. We actually talked a month or two ago, but
Yeah,
it's a pleasant conversation. So thought I'd bring you on. I guess for people who don't know who you are, do you want to give a quick intro?
sure. My name is Toby. I'm the CTO of Typico Data. So Typico Data is a new startup. We make SQL Mesh, which is a data transformation framework. Before starting Typico Data, I led analytics at Airbnb, and then before that, I was one of the architects of the experimentation platform there. So
Dang.
yeah, been around data for a while. Excited to kind of start my own venture with two great co-founders. So yeah, thanks for having me here.
Yeah, anytime, anytime. It's fascinating. I'd like to maybe kick it off talking about the progression. I mean, you worked in. Would you consider Airbnb to be big tech or just a bigger tech?
Yeah, I would say that it's big tech. I would say that within big tech, obviously there's tiers, right? If you're looking at scale of people and scale of data, you have things like I don't know Apple and Facebook at the very top. Then maybe a Netflix, which is pretty good, or sorry, pretty big, but not quite Facebook level. And then
Hmm.
something like Airbnb, which is larger than most companies, but not even near the level of something like a Netflix or Facebook.
Hmm. Yeah, it's but you see this progression a lot. I mean, when you decided to leave that world and do a startup, were you had you already open sourced something? Because it seems like the progression typically is maybe you're working on something at say big tech co, it becomes an open source project, then you decide to leave to start a company around it. Was that your progression, or was it something else?
Sort of. So when I was at Airbnb, I worked on Minerva, which is Airbnb's metrics semantic layer.
Hmm.
And while I was there, I was thinking about doing kind of like a semantics layer startups. It was kind of hot back then. A lot of folks were doing that, like Transform and
Hmm.
other folks. But I realized quickly that a semantics layer can't really live on its own without owning transformation, right? Like the hardest part of doing metrics and semantics is transforming the data. And so that's kind of where the idea for SQL Mesh came. So we didn't start Topico data with SQL Mesh, but when I was at Netflix as a hobby project, I started creating a SQL parser called SQL Clot. And so SQL Clot is like a Python library that allows you to parse, understand, and transpile SQL. And so I kind of wanted to use that as the foundational tool to build a new transformation framework so that your transformation framework could understand the SQL you're writing. So you don't need like explicit ref tags or a bunch of YAML files anywhere. You should just be able to write SQL and have that all work. So that was kind of my vision.
What inspired that? This isn't like the most intuitive thing in the world.
So I work a lot with data scientists and stuff like that. And data scientists really just want to write SQL, right? They don't want to write config files, they don't want to write Python code. But the problem with writing just SQL is that you don't have enough metadata that you might need to build some kind of engineering system with metadata, right? That's why things like DBT, for example, have you write explicit ref tags or have you define schema in YAML files because they don't really understand the SQL you're writing, so they need you to explicitly tell them. And so I realized that in order to kind of allow people to write the language that they're used to, SQL, you need to understand it. And there was no real good parser for SQL at that time. The only thing that really existed was SQL parse, but that's actually not a parser. It's just a tokenizer.
Hmm. That's interesting. And how widely was it adopted over at you said Netflix?
Oh, it wasn't really used at Netflix. No,
Okay,
it was just a hobby project
hobby
that I
project.
had
Oh,
built.
cool. Even better.
But I brought it into Airbnb and used it quite heavily in a lot of the work there, and it is quite fundamental now in
That's awesome.
driving a lot of Airbnb's internal projects.
Really. And I heard about Minerva. I think there was an article that came out about that many years ago, but it was never. I think the big question mark was at school. Nice article. Um, will we ever get to see this in action? So
Right. That's the thing with some of these projects at big companies is that open sourcing is never really the priority, right? The number
right,
one priority for any company is that these tools serve the stakeholders and provide value to the business. And open sourcing, most of the time, is a cost, right?
yeah.
The team has to maintain it, has to manage relationships with the open source community. And so it's just not a priority to open source it. But I'm not involved with that anymore.
I guess the question, what I always had is if people can't get their hands on it, but you sort of loosely describing what these tools do or these approaches. Why write an article in the first place? I mean, there's a cost to doing that too. Is it? I've always wondered that.
Well, the folks who are writing it, the engineers writing it, they get to have some kind of publications, right? And so it's a good experience for them. But it also can serve as a recruitment tool, right? People will read about it and then maybe want to work on it. So there are a couple benefits there. And writing a blog post is certainly much easier than open sourcing and maintaining a project.
Oh, the maintaining part too, especially, is just insane.
Right.
So it becomes a job. I mean, I think big companies like Google. I mean, they have lots of full time people just working on open source. I can't remember how big the TensorFlow team was employed full time at Google, but I think it was like the size of some startup companies or bigger, actually, like
I'm
well
sure.
funded ones. Yeah, so it's just like that's all they do is just work on TensorFlow all day.
Right.
Yeah, it's interesting. So you dropped off. So you worked in Airbnb. Um, you jumped up to a startup, but like, what were I guess when you're leading analytics at Airbnb or architecting some of the data platforms there, like what were some of the learnings that you wanted to take away and make a startup about? It's
Yeah, there were a lot of new things to me. So being kind of in bigger companies for the last couple of years, I was kind of put into the big company silo. So in my mind, everybody in the world used things like Spark and partition-based orchestration tools like Airflow, right? But then when we started SQLMesh and started interacting with people around the world doing transformation, it seemed like most people use BigQuery and Snowflake, right? These are tools that I had never really worked with.
mm-hmm.
And so kind of shifting away from the FANG mindset was a little bit different there. That was kind of a shock, but we quickly adapted, right? So when we first designed SQL Mesh, we thought, okay, SQL Mesh is going to be built for the Spark Airflow user. That's like
Oh,
our
interesting.
ideal customer. But then everyone started saying, "Hey, I want BigQuery. Hey, I want BigQuery." So now BigQuery is actually our number one supported kind of warehouse.
That's interesting too, because if you there's always a big tech company mindset where even if you you know talked to Jordan Tigani about this, the guy who built BigQuery, and it's funny because even in Google at the time when they built it, now BigQuery is sort of seen as a data warehouse, but he was telling me if you use the term data warehouse, trying to recruit engineers to work on BigQuery back in the day, they would run the other direction, like because it wasn't a cool tool to work on, and so it's so they had to adopt when they started selling BigQuery, I guess, right? They had to start adopting their own big tech mindset to the rest of the world, which and so that was a translation in itself. And it's interesting you saw kind of the same thing where it's like, oh, everybody obviously uses Spark and Airflow, everyone in the world. You
Right.
get out there and it's like, maybe not.
Yeah, maybe
So
not.
that's interesting. Um, the BigQuery one is interesting too, because I feel like that's a tool it doesn't have like the biggest market share, but it's incredibly powerful and easy to use. What are you seeing with like the adoption of your tool with BigQuery? Because it's like again, it seems like it's the people who use it. It's just like a hardcore fan base.
Yeah, I'm not exactly sure. Um, for us, right, BigQuery is the most popular. It's probably not representative of the overall population, but
Yeah.
BigQuery, in my mind and from my experience, is quite good. I think that it's got a very understandable business model. Like you just pay for kind of throughput or bandwidth or whatever, and it's extremely cost effective. So I can kind of see why it's so popular. Um, yeah.
Well, yeah. Yeah, Snowflake's an interesting one. I think that's the one that's got the most mind share and market shares from my
Yeah,
perspective there. So,
it does, and we do support it, and we have some clients on it. Uh, I don't know too much of the nuances between Snowflake versus BigQuery, but from my perspective, Snowflake is kind of the black sheep of the data warehouse world in that it it has very different kind of syntax compared to the rest. So one of SQLMesh's kind of goals is to make it so that you don't have vendor lock-in, right?
mm,
Because it's built off of SQL Glot and it understands your SQL, it can also transpile your SQL. So, for example, if you write all your models in BigQuery, but then decide later to switch to Databricks or Snowflake, we could do that, right? But one of the problems with Snowflake is that they inherited, I think, from Oracle. And so by default, all of their identifiers are uppercase. But the
mm.
rest of the world, right, everything outside of Snowflake and Oracle is lowercase. So there's like a lot of gotchas there to make that compatible. It's really annoying.
Oh, I can imagine it's super annoying when you're the one maintaining this library. That's
Right.
interesting.
Yeah.
That's interesting. So you left big tech, started SQL Mesh, and then you have an open source version. So like, walk me through this. It's something I like to ask founders of these kind of hybrid open source companies. But like, how do you balance that tension between open source and trying to commercialize?
Yeah, that's a great question. And it's something that we're still working out, right? We're a pretty new company still, only been around about a year and a half. And so we've really spent the first year since starting the company developing a strong open source offering. But at the end of the day, we are a business, and so we need to try to make money. And so we're thinking about it. We're prioritizing this year in creating a compelling cloud offering. And so the cloud offering will obviously be hosted, right? So SQL Mesh has a concept of state, right? So within SQL Mesh, we kind of keep track of every version of every model you've ever had, as well as for what dates or partitions you've run every model, right? So there's a lot of metadata that we need to store. So it's natural for us to want to have a hosted version of that so that you don't have to manage the state yourself. So that's one aspect of it. Other aspects of it are we're going to like log additional metadata and stuff. For example, run times, errors, costs, right? And we're having that be a part of the enterprise offering. So we have this
Mm,
whole observability layer that isn't a part of open source. But the way we kind of try to split it out is that we want open source to be powerful and standalone and ready for anybody at any scale to use. And things that go in enterprise should be like, well, if you're a bigger company and you really want to run SQL Mesh in a stable and scalable way, then you want to use enterprise. Obviously, it's kind of an art to deciding which one is which, but that's kind of where we're at right now.
hmm How do you view the landscape of transformation and data observability tools right now?
Well, obviously, I think in transformation, DBT is pretty much the king, right? It started it all. It kind of maybe coined that term, and especially the analytics engineer. So that's one aspect of it. In terms of observability, I think there's a lot of different players in the game now who kind of look at observability in data from maybe a 10,000 level kind of view. SQL Mesh is trying to more tightly couple data and observability, right? Because SQL Mesh understands your transformations and what has changed, it can then tie all those observability metrics to the exact commit you've done, right? So I think current observability tools, regardless of whether or not they have AI or whatever, they can kind of say, oh, something changed Maybe it takes longer to run, but it doesn't exactly tell you why. It just says what
Mm.
happened. SQLMesh observability is trying to tell you not only what happened, but why it happened.
How do you know why it happened?
We know why it happened because we have the granular understanding of what exactly changed
Hmm.
and what was impacted through that change, right? So when you change something, though that change can impact runtimes and cost. So we can directly associate any anomalies to that exact change, allowing you to quickly triage and fix issues.
So one question I always have for observability folks is, uh, how do you know what's an anomaly and what's noise?
Right? That's obviously a very very difficult question. And we don't solve that today, but we do provide kind of visualizations to let you know when things spike. It's kind of up to you. I would say that even a lot of the top companies, right, Airbnb or whatever, they haven't figured out anomaly detection. So there's obviously a lot of
Oh,
statistics involved, and machine learning is possible, but having noise and all that stuff is a very challenging problem. So I don't have a good answer for you there. But
no, that's an honest answer.
right,
So it's a good enough answer, right? Yeah, I think it's one of these things where I struggle with because um, I think there's a lot of false positives,
right,
which ain't a bad thing either, right? I think you'd rather be alerted than not. But the problem is, you got to balance that against alert fatigue, which is
right.
it's a real thing, like a real thing. Because I think that's like one of the reasons that I see observability tools sort of, even see it as a Datadog, it just sort of fades into the woodwork after a while.
That's exactly right.
Yeah, so it's an interesting balance, but I think the causal stuff like why, that's an interesting one. You know, 'cause I think you're right. It's most of these tools tell you sort of what happened and sort of a pinpoint, but then you got to go figure it out, and that takes a ton of time. So um, I guess you're capturing a lot of metadata. I mean, that's a pretty interesting thing. So I don't see a lot of tools capturing state in quite as much of an intentional way.
Hmm.
Like, walk me through this. Like, how did you realize that capturing state and the associated metadata would be an important thing to keep?
So this concept of like capturing state and for both your model definitions as well as what partitions and intervals you run with isn't my idea, right? This is something that all the big tech companies do.
Yeah.
For example, Airflow is a partition based scheduler, right? Airflow has a concept of, okay, you ran these tasks for this day, right? So
Hmm.
that's one set of state. And in terms of capturing SQL definition state, right, when you have hundreds or even thousands of engineers and analysts making changes to things, you can't just kind of treat them all as individuals. You kind of have to understand how things change, what needs to be backfilled, etc. So one of the motivations for bringing kind of this state tracking, right, to the open source world is that when I first saw a demo of dbt, I was pretty shocked. The person demoing it was like, okay, I'm going to make this change now and I'm going to refresh all of my models. And I'm like, whoa, 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 whoa. What do you mean refresh all your models? You just changed
Yeah.
one of them. And he's like, oh, well, this is how you do it in DBT. There's no problem with refreshing your whole warehouse. And I was like, oh, well, that could never happen at Airbnb, right? We have too much data. It would take too long and
Yeah.
be too expensive. And so I was like, well, DBT is so popular, yet they're still refreshing the entire world every time you do DBT run. Why don't we bring kind of what some of the bigger companies do at our scale so that everybody can kind of have more efficient refreshes? And so, in order to do more efficient refreshes, you need to understand what has changed,
Hmm.
what's been impacted, and what has already run.
Interesting. So you're taking more kind of a maybe a lazy evaluation stance with a lot of stuff, or is it a so Airflow captures all the state, but for transformations, it's a bit of a different story. Like I don't see a lot of data transformation tools uh, taking I think such a detailed approach, right?
Right.
So it just doesn't happen. It's like you run your SQL, do the transformation, done.
Exactly. So Airflow keeps track of, like, for a particular task, what days you've run for it,
Yeah.
right? That's the state. But it doesn't understand, for example, oh, I added a column to this
Yeah.
task.
Yep.
And so I do need to backfill this task, but all the downstream jobs, they don't care about that column. We don't need to do anything, right? Airflow doesn't have that understanding, the semantic understanding of SQL to make that kind of optimization. Whereas SQL Mesh is really built around that kind of column level lineage efficiency optimization.
One question I have, you mentioned SQL. There's sort of this other universe of data frames where data scientists are doing transformations using maybe pandas, polars, whatever. Um, have you included I guess those people in your world as well, or
Of course, yeah.
yeah?
So doing transformations using Python is very important. And so SQL Mesh includes Python models. And so you can do whatever you want in a Python function. You can even hit an API. You can write PySpark code, Pandas code. As long as you return a data frame, then the whole thing still works in the ecosystem. Now, obviously, because you can do anything you want in Python, we don't have uh, granular column level lineage there, but we do expose an API where you can kind of define the schema, the expected schema of the model. And so table level lineage still works using Python models in SQL Mesh. Sorry, you're on mute.
Of course I am. I was coughing and talking. So one thing I'm going to ask is, what are some anti-patterns when it comes to data transformations, whether we're talking about SQL or data frames?
I guess some anti patterns with transformation is denormalizing everything a little bit too quickly, right?
Mm,
I think that sometimes folks will kind of join a bunch of tables and make a super wide table. But when you do that, things go stale, right? Because if you join a dimension table to a fact table, whenever those dimensions table change, in order for that to be reflected, you're going to have to do that expensive join all over again. And so when I try to design data models, I try to keep everything separate until you actually need it. Sometimes, obviously, if you want a dashboard to be really fast, you do need to denormalize, but overly aggressively denormalizing, I think, is kind of a bad habit that people have.
why do you think people jump into that so quickly?
I think it's easy, right? People kind of don't think about the costs associated with it. And at the end of the day, if your stakeholder, some kind of person in finance is like, hey, I need my dashboard to be faster, you kind of say, okay, well, I'll just join all these things for you so that
Hmm.
you have it.
Yeah, it
It's kind of
happens.
yeah, it's kind of an easy way to kind of patch the bleeding or whatever.
Yeah, and it seems like I'm thinking a lot about data modeling these days, and I think there's a few other things too where it's the yeah, you point out somebody from accounting needs something, so that's going to be a lot of ad hoc reactions to getting that answer or that report to somebody, and that's you're going to do whatever it takes to get to answer that question. But then that starts having its own sort of technical debt and data debt you start piling on.
Right.
And then the other part of it is, I think in the last, at least in the modern data stack era, sort of one big table was sort of the gospel. At least it's what in DBT's official course, that's what they would teach is one big table
Right.
out of the gate, right? Just throw it all into one big table and be done. And it's certainly one approach to doing things, but there are trade offs,
Right.
like a ton actually. So
And it's easier to add columns than to remove them. So
yeah,
that table is going to get wider and wider and wider.
hmm, it's going to get wider and it's also going to get staler, right? I
Right.
mean, there's a reason that if you take a step back to the 1970s, the relational model was built to remove dependencies among different data sets. It wasn't about database performance per se. It was about the fact that you could rationalize data better when you don't have partial or functional dependencies between data
Exactly.
sets. And that's something I feel is lost where it's like, oh, just we treat everything sort of as a giant Excel file right now.
Right.
So it's
Yeah, and an interesting kind of anecdote is at Airbnb, Minerva was kind of created to solve this problem, right? Because they used a wide table and it kept
Mm.
growing and growing. And the problem is that sometimes different data sources come in at different times, and sometimes they're late. But if one data source out of 200 is late, you don't want to delay the whole dashboard. And so now you have this complex system managing all these dependencies with different SLAs. And now you have this fat table with thousands of columns, and some
Wow.
of them came from yesterday, and some of them came from a month ago. It's pretty crazy.
Wow. Okay, that sounds like a fun jigsaw puzzle.
It's not fun at all.
No, I'm joking, of course. Yeah, how the hell do you deal with that?
Yeah, exactly. And so with Minerva V2, right, which I kind of helped design, we only cache when necessary, right? We're like, okay, well, a lot of the tables that we have are actually quite small, and the business analyst only needs 1% of these columns. So let's do the long tail on the fly, right? Join stuff on the fly when it's necessary. And for the bigger tables or columns that we know are going to be used in 90% of the queries, then you can denormalize them, right? So
Hmm.
more of a lazy approach.
Yeah, it seems like it. I mean, without, I mean, you don't have to mention details if you can't, but like, what were some of the data modeling best practices over at Airbnb?
So we try to denormalize only at the very end. That's one thing. So all the core tables are normalized. So you have your dim tables and your fact tables. That's one part of it. Um, we try to only have one source of truth, right? So all of the transformations and metric definitions were supposed to all be in Minerva. Obviously, that wasn't always the case, but we tried to get there. And then we also had uh, kind of a program called Midas. And so it's basically a way to get your table certified and a part of the core data systems, which can then be used downstream to power more important reports.
Walk me through this. Like, what's the how do you know when a table should be certified? It's an interesting notion.
Actually, I don't really know that.
Okay, it's an interesting one. I've seen this at other companies where it's done by committee. So you sort of have the I don't know the lords of the tables or something. I don't know what you call it, but
Yeah, there's probably some
they
kind of
bless it.
committee
Yeah, it's
kind of
interesting.
guidelines that they have to follow, check some boxes.
Bless it.
Yeah,
That's,
bless it. Yeah.
that's interesting. Yeah, it's this feels like this is one. I mean, when we get back to data transformations and whatnot, it feels like it still seems like a really hard problem to solve. It always has been, but I'd like to think we're making progress as an industry. But as I've been researching back, since the dawn of data, it seems like we've been in the same spot in the sense where data is hard to use, especially when you're doing it for analytics or experimentation. It's just every day is a different adventure, and so I don't know if you feel the same way or if you
Oh,
see.
absolutely. So
Yeah,
one of my specialty fields is experimentation, so I know kind of how hard that field is, not just getting the data where you need to be, but interpreting it, right? There's like a lot of
yeah.
gotchas with looking at experiment data. For example, you can't peek, right? That's kind of one rule.
Hmm. Why can't you peek for the audience? Tell people why you can't peek at the data.
So for people who don't know what experimentation is, uh, a common form of it is A/B testing. So, for example, if you want to know on your website whether a red button is going to get more clicks or a green button, right? The only real way to truly prove that is through an A/B test or an experimentation, right? An experiment. And so what people do is they have two versions of the website, one with a red button and one with a green button. And they're going to randomly assign 50% of the people to each button. They're going to collect metrics. They're going to see how many people saw each one of those buttons and then how many people clicked on those buttons. And then through statistics, right, they can calculate if one over the other had a statistically significant impact or change. And when you do this, you need to kind of have enough power. You need to have enough data to be sure of your assumption or of your hypothesis. And so as the experiment is running, right, there's a lot of noise, right? Sometimes someone might be more inclined to just do it. And so they might click the button more. And so there's the graph of success is going to bounce up and down. And so if you're constantly looking at the graph and saying, oh, green is better now, red is better now,
Yeah.
right? If you're checking too often, you can kind of cherry pick whatever you want, right? And so it's best practice to kind of set an end date of an experiment given how much exposures you're going to get so that you only look at it once. Because every time you check, there's a percentage of error, right? It's called a type 2 error. And every time you actually look at the graph to make a decision, you're going to be exponentially compounding that error. Sorry, I don't know if that was a little bit too technical.
No. I think it's a really actually a pretty uh, elegantly simple explanation of it. Because you didn't dive too much into stats speak. So, like p values and all this other fun
Right.
stuff. Yeah, the peaking problem is an interesting one because I think it would be tempting to once you start. Well, I mean, one of the things you see in experimentation often is when you start getting results that validate whatever it is you think you want to validate, you just stop it because your work's done.
Right.
So and it's like cool, just um, but that happens a lot.
Yeah, and so at Airbnb and Netflix, for example, people always want to know the data a little bit faster, right?
Yep.
And they want to peak. It's natural human instinct. And so a lot of the time, the data scientists spend a lot of work on design using statistical methods that allow for peaking, right? Either moving to Bayesian or uh, I forgot the words for it, but like a sequential method, right? And in
Mm,
those methods, you can actually look as much as you want. But the trade off there is because those methods are designed to be peaked at, they actually lose power,
yep.
right? So it's kind of a catch 22 because you could actually get a result faster if you didn't have these methods, right? Because you wouldn't lose the power, but then people want to peak. So,
Hmm. Yeah, and this is interesting too. I think when you're talking about experimentation, um, and it's something we actually talked about on a phone call when we first met. But it's like, what are the downsides of using real time data for experimentation or streaming data?
so I guess before we delve into there, what do you mean by streaming? Do you mean like
Continuously flowing data, right? Versus getting data in at set intervals.
so you mean, for example, even something as low as like sub-second latency, or are you talking about like micro batches like 5-10 minutes? Like is 5-10 minute batches still real time, or do you really
Well,
mean
real time's in the eye of the beholder. That's why I said streaming to
right?
illustrate more of a continuous fashion of I guess never-ending flowing data. So maybe one way to think about it, and this is an interesting one. This always comes up when you mention streaming real time, but I like to take the notion from the data flow paper of bounded versus unbounded data, right?
Right.
So unbounded would be streaming in this case, which is continuous flow. Then bounded would be okay. I'm going to pick a subset of this continuously flowing data and call that a quote batch or a quote micro batch. And so,
Right.
yeah.
So within the kind of experimentation world, um, doing things in a purely streaming fashion, so unbounded, event based, is quite difficult just technically because
Hmm.
you have to be able to assign the event to the treatment, right? So let's say you're getting a flow of clicks or a flow of impressions, right? If you're at a large scale company, that could be a huge, million RPS stream. But then for every single event, you have to label them. Okay, this user was exposed to this variant. This user was exposed to that variant, right? And then to do the proper statistical analysis, you have to then like do all this aggregation and stuff like that. And so that kind of whole flow would be difficult technically to compute uh, on demand. Um, and so, just from a technical perspective, doing things in a batch world, even once an hour or once a day, is feasibly much easier because the types of things you need to do, joining data,
Hmm.
aggregating data, filtering, etc.
Yeah. Yeah. I think it's one of the nuances that I later reflected on in our call where I was like, okay, yeah, I think Toby's got a good point because we're talking about the notions of streaming and
Right.
batch and whatnot. And I think I asked if SQLMesh was streaming tool, and you're like, nah, we're not. It's like, oh, okay, well, that's cool. So
Well, so yeah, SQL Mesh is not designed for event-based streaming, but if you're talking
yeah,
about, for example, a 5-minute micro batch, it
yeah,
works perfectly well for up to 5-minute micro batching.
yeah.
Now, I will say at Airbnb, we designed a real-time kind of A/B testing system to detect regressions and deploys, right? So whenever
Oh,
Airbnb
cool.
deployed software, they wanted to know in real time, within minutes, if their version of software broke things. And so that was a very specialized system designed to take in real time streams and use specialized uh, statistical methodologies to detect that. But that was, a very bespoke system. It wasn't designed for, kind of these more business oriented metrics and experiments. It was really designed to know this one crashed more or this one had more latency.
Yeah, these are much different questions.
Right.
Interesting. So they didn't have a like a regression suite set up for the testing before deployment, or
Well, they do, but it's difficult to do that beforehand, right? In
yeah,
order to know if it really affects users, right? There could be a lot of variables out there that you can't measure
true.
beforehand.
Yep. Yeah, especially I guess at the scale of Airbnb, there's just all these like long tail things that would be hard to account for. So
Exactly.
yeah, it's interesting. Yeah, I guess it's the old it works on my laptop doesn't really apply at that scale. So
Exactly. Right.
that's interesting. I mean, walk me through that though. I mean, what are some of the when you're talking about doing experimentation for analytics, right? Like what were some of the things that surprised you as you got into that role and we're doing it at Airbnb? Because you're doing it's not like you're doing some sort of like small time experimentation in a lab at college or something. I mean, these are massive data sets with a ton of users.
Right. So not only are there a lot of users and a lot of data, there's also a lot of concurrent experiments, right?
Mm,
So at any time there could be hundreds of different experiments going on, right? And so different experiments could actually affect each other, et cetera, right?
yeah,
And so there's a lot of complex statistics that can be used to kind of filter out that noise so that you can get a better read on your experiments. And so my work at Airbnb and Netflix was really to help enable these really smart, statisticians and make them more effective with data, right? So it was kind of my job to build the data tools, build the infrastructure such that they could extract all the good nuggets of information from the experiments. And so at Airbnb and Netflix's scale, it's very difficult for a non-data engineer to like fetch the data and do
mm,
everything they need in an efficient way. And so that's kind of where my background started. I needed to figure out how to get anybody, even the less technical users, the ability to work at Airbnb and Netflix's scale.
wow. That's a really simple sentence you just said, and it sounds insanely difficult.
Right.
How does it work?
So that's kind of like the start of SQL Mesh, right? But like,
Yeah,
how can you let someone who really only knows how to write SQL, how can they just write SQL and have that be efficient and work at any scale? That's the goal, right? Because if you have them write something else, they're not going to be as effective. They're going to make mistakes. But if you just have them write SQL and you put in some safeguards, like say, oh, hey, you wrote this SQL, but you really need to have these filters, right? Or else you're going to scan the whole table, right? That way they can focus on the business logic, they can focus on getting the data, but then you kind of put in checks to make sure they're doing it in an efficient way. And for example, let's say they make a change to a core table, right? It would be first of all, it's impossible at these larger scales to be able to refresh everything downstream. It's too expensive, right?
hmm,
So instead of putting that on the user to say, hey, you made this change, you need to figure out all of the downstream tables that have been affected. Can we build the tools to know that you changed this? These tables use that data, they need to be backfilled,
yeah,
right? And so it's about building these tools to ensure that they're always doing the right thing in the most efficient way possible.
That's awesome. Like I said, that's a good goal. It's insanely difficult to do. I mean, I meet with a ton of data teams, and just the simplified workflows, I think, is a big thing. And it feels like a lot of tooling vendors don't approach that from a place of empathy, right? Where you're trying to make the analyst experience as simple as possible, for example, but empower them with the ability to do awesome things that a data engineer could do. I mean,
Right.
a lot of people speak to it, but when I look at the tooling that's involved, I'm like, it's certainly could be easier. So
Exactly right.
yeah, that's interesting. So, we're recording this, middle of February. So DBT's CEO, Tristan Handy, penned an article the other day, basically the modern data stack and how we need to move on from it. I don't know if you got a chance to read that, but what are your thoughts on the modern data stack and sort of where it fits into today?
So I actually had never heard of the term modern data stack until I started to think about building my own
Oh,
startup.
no way.
Well, because at a FANG, right, you're just thinking, okay, the data stack, right? I knew of BigQuery, Snowflake, etc.
Yeah.
But in my mind, I had never heard that term. I just thought, okay, well, this is just big data. This is pretty standard stuff. And so I guess to me, the modern data stack is just like a conglomerate term of all these disparate tools that perform some function of like extraction, transformation, loading, etc. Uh, and so I think that it's kind of uh, at the beginning, right, of the MDS or whatever, everybody is trying to find a space, carve it out, and then become a player there. And so there's just going to be a lot of tools. I think over time, the number of tools will shrink. Other companies will absorb functions, and so it'll be more isolated down into bigger but wider players. So,
Hmm.
yeah.
Oh, that's interesting. Well, that might be a good thing you were sort of immune from the zeitgeist of the modern data stack hype, because it was it seemed like in the when about what did you decide to go out and do SQL Mesh? What year was that?
So we started SQLMesh in September of 2022.
22. Oh, okay, yeah. The man after the party ended, so to speak. So we'll talk about that in a second, but. Well, yeah, I mean, I recall. I mean, to your point about like endless amounts of tooling vendors, it was. I don't know if you ever seen Matt Turk's Mad Data Landscape, um, the infograph with like all the logos.
Yeah,
I
yeah,
think there's like 1 million or 5 billion logos or something like that. I
right,
joked to them that you'd have to use the James Webb Telescope to see everything on there. It's just like so insane, but it definitely felt like for every category, there's just I don't even know how many countless vendors, right? And my whole question was, well, is this growing the total addressable market for this category, or are y'all just fighting over what is pretty much a fixed pie? And in which case, if only 2 to 3 vendors can really obtain market share of significance, what happens to everybody else, right?
right.
So, and that was also a time when like it was. I mean, you could have a pulse and basically get money from VCs for a water data stack company, but in 2022 that changed, right? I mean, it was a
Right.
much different situation. So why,
Yeah,
why, why the hell did you decide to start a tooling company in 2022?
just timing. I've always kind of wanted to start a company. Same with my brother. So my
Yeah.
brother's actually the CEO of the
Oh, no
company.
way. That's cool.
Yeah, and when we have another co-founder, Yaroslav, who's a good friend of mine, I met at Netflix. But we finally decided to pull the trigger after the party ended, as you say, and the funding had dried up. Right in September of 2022, VCs were not giving away money like candy like they used to, and so it
No.
was it was tough for us to get funding, but uh, we were able to get kind of terms that we were happy with, and so we took it, and it's been really fun. I'm so glad that we decided to start the company. Um, yeah, and I've just been having a blast doing it.
What are you liking about it?
Being able to work with such a great team, right? Starting your own company, you kind of get to handpick your team. And so being able to work day to day with such a strong team, it has been really fun for me. Additionally, kind of being the underdog and doing what people think is impossible. So back in 2022 of September, DBT was still the darling of the industry. Everyone thought DBT was untouchable, and everyone was happy with DBT, and there would be no room, even though there is no competition in transformation, for another tool. And so I think that in the last year, we've kind of shown that there is space for another transformation tool, and
Hmm.
that we can be a part of the conversation. So I've kind of had a lot of fun, not only building out the product, but also helping to gain mind share that there could be a better way to do transformation.
Yeah, it's interesting. It's interesting timing too. I think that and full disclosure, DBT's good friends of mine, and didn't work with them, and Tristan's a friend. So, but it is interesting. I think the competitive dynamics, because you're absolutely right. I mean, DBT took the world by storm when they came out. I think it's even in the late 2010s, right? I mean, they're starting to get wide adoption. They're open source. Was super popular, and the community grew like wildfire, right? And but you fast forward to today, and like every other data tooling company that sprouted out in that era, I think there were just a lot of expectations on what DBT was supposed to be doing as a commercial interest, and so that forced them to start acting like a big company, right? And they did some things I think that may have irritated some of their customers. The audience can go and read about that online if they want. But it's an interesting one because I think what it did show is that, and the fact that Tristan wrote this article, which about the modern data stack and moving beyond that, I think illustrates that nothing's permanent,
Right.
right? And there is a chance. I mean, I'm seeing SQLMesh popping up all over the place in conversations now, which I didn't see last year, and I do have a very good ear to the ground and what's going on. So
Don't get me wrong. I highly respect DBT.
yeah,
What it's done for the industry is game changing, right? They invented the whole analytics engineering field. They really changed the game here. But it's just you get to learn and from the shoulder, or you get to step on the shoulders of giants, right? And so we learned a lot from what DBT accomplished, as well as kind of our team's background comes from a little bit of a different perspective, right?
yeah,
DBT, RJ Metrics, or Fishtown Analytics, right? They really were geared towards making Series A companies successful with data, right? Getting them up quickly and
hmm
running. Whereas our team primarily comes from big tech FANG companies. And so we're coming from a perspective of, well, how can we make analysts and scientists effective at
yeah.
any scale? So,
Yeah, it's exactly right. It's a completely different approach. I think when we were talking last time, you said it's companies of all sizes, right? But the thing
right.
is, you came from a big company, you can only work down from there.
Exactly.
Versus, which I think is much more. It's a much different problem than starting from focusing on startups and trying to move out into the enterprise. It's a far different game.
Right. And so, DBT may be working on, for example, how to scale DBT. On our side of things, right, we're working on, well, how can we make it easier for the smaller companies to adopt SQLMesh, right? Because SQLMesh already scales, but due to what we need to do in order to make it scale, there's a little bit more complexity involved there, right? And so, because we're coming from it from opposite sides, we have opposite kind of problems.
Hmm. I mean, it's an interesting problem too. I suppose the thing is when you're I mean you are going to have to go head to head, right, with DBT and other transformation companies out there. I mean, but there's also a certain stickiness, right? I mean, there's the old common trope that a lot of companies have thousands of DBT models laying around, and these things, I mean, they're inherently sticky. I mean, do you plan to unseat them, or do you plan to just go for new workloads, or what's the approach?
Yeah, that's a great question. So, one of the kind of most important features that we have is we have a DBT adapter, right? We understood and recognized how popular DBT was. And so we made sure that SQL Mesh is compatible with DBT. So you can take an existing DBT project, not do any changes, and run it and take advantage of all of what SQL Mesh has to offer, right? So we can read in a DBT project, and then you get column level lineage, you get efficient environments, you get all this state added on.
Nice. I mean, they just announced column level lineage the other day for the cloud product.
They
So,
did, yeah.
yeah,
Which is yeah, leveraging kind of our work, which
interesting.
software, right? Yeah.
It happens. So it happens a lot. Yeah, it's an interesting one. I'm curious to see where this all goes. I think that, yeah, I think the benefits. Okay, so if you kind of rewind to the days beforehand, though, right? I mean, data transformations. If I were to rewind, probably 15 years ago,
Hmm.
right? I mean, this is it sucked. That the world was hard. It was a lot of proprietary tools that some drag and drop, but a lot of them were just very kludgy workflows, right? And that's those are still around. Those would be workloads you got to unseat still because despite how kludgy they are, they still work, and companies pay a lot of money for them. And DBT comes along, I think, sort of democratizes, makes simpler in some ways. I think complicates things in other ways. Transformation workloads, and here we are today, right? But what's interesting about today is there's also the rise of AI and AI. It seems like every company right now every data tooling company is embedding AI into its workflow or doing something with AI. Do you have an AI story that SQLMesh is adopting or?
Just like everyone else, we kind of spent 5 minutes integrating AI into our app. So there's like a CLI in SQL Mesh where you can use English to kind of get a query, right? Because we kind of hold the business logic for all the complex things, and we have metadata. And so by piping that through OpenAI, you can kind of ask questions. At the end of the day, it's like a fun demo, and I think that right now at its current stages, kind of LLMs make for really good demos. But whenever you get something a little bit more complex or require something a little bit more nuanced, I don't think it's there yet. I think that LLMs can help a lot with certain fields, maybe like summarization or
Mhm.
customer support or something like that. But it's still not quite there yet for programming or even doing data analysis.
I tend to agree. And it's a weird one too, where I think if you start introducing LLMs into engineering workflows, which I think some companies are trying to do, we always joke that you're going to have to start doing prompt reviews and
Right.
all this other stuff. And I don't even know how the hell that works when you're dealing with a non-deterministic system that just sort of spits out things.
Well, you can provide seats now, I think, and so you can
Yeah.
but it adds a lot of burden for the reviewer, right? Because now the
Mm.
reviewer is like, huh, this looks fishy. Did you write that, or did the LLM write that?
Oh yeah.
Yeah, so uh, I don't use it, but then again, I'm kind of old fashioned. I still drive a stick shift.
Oh, you do.
Yeah,
No way.
I like to have some control over things. I would say that for me, if my car could drive me 100% of the time anywhere, I would be fine with an auto driving car. But until then, I'd rather have more control.
Interesting. So let me ask you, why not an automatic?
Manuals are just more fun. So back in the day, I used to hypermile a lot, and you can't really hypermile in an automatic car. And
Yeah,
so
I guess that's true. Oh, I didn't know that about you. That's pretty cool.
yeah,
Do you still
but
do it?
hypermiling, no, it's too much effort.
Explain hypermodel miling for the audience. If they,
So hypermiling is kind of the art of getting the most mileage out of your car. And so there are various techniques that you can do. So basic things like trying to use the brake less, right? Having more space in between people so that you can cruise more, and not speeding. Those are basic techniques. If you want to go more advanced, uh, your engine is actually most efficient at about 80% load. And so
interesting.
what you want to do is you want to accelerate at 80% and then cruise down to some lower minimum. So for example, if you could accelerate to 35 miles per hour, cruise down to 25 miles, and do that over and over again. So that's called a pulse and glide. So that's like a technique that you can do to increase your mileage.
Huh.
Yeah.
I didn't even know this was like a thing. So
Right.
when I met the audience, I mean, yeah, educate me too. That's crazy. But that seems to be impacting your work as an engineer. So that's
No, it's more that I think I have a kind of personality that leads me to like those things more. And so,
yeah. Okay. That's kind of fun. I'll have to try that sometime. I have an automatic though, so I don't know. I mean,
It'll be harder to do in automatic. Probably not worth it.
yeah, I mean, one thing I do in an automatic, and I picked this up in Asia, is I just if I'm parked at a stoplight, I just I put everything in neutral.
Oh, okay.
Yeah, takes less load off the car because otherwise your car wants to keep going.
Mm.
Yeah, all the drivers in Bangkok, I know all the cab drivers are doing that, and it's like, why do you do that? And it's like it's less stress on your engine. I mean, because they're stopped all the time given the traffic there. So for those,
But these days, cars have the auto stop feature, so when you're at a stoplight, it'll turn off your car
yeah,
engines.
mm, mine doesn't have that.
Oh, okay.
So yeah, so I can turn it off, I guess, but I have to turn
Yeah.
it back on.
Right. So I used to at stoplights turn off my car manually.
No way.
Yeah.
That's something else. I've never met anyone that did that actually. That's pretty cool. So, well, awesome. It's been great chatting with you. Yeah,
Yeah. Thanks for
truly.
having me.
Yeah, yeah. I think I think you're definitely onto something with SQL Mesh. I'm excited to see where things go for you. For people who want to learn more about you and what you're up to, how can they do that?
Yeah, you can go to our website, SQLMesh.com, and we have a Slack channel as well where we
Oh,
chat about data and stuff like that. If you have any questions, it's at tobicodata.com/Slack.
where does the name come from, by the way, Tobiko?
Tobiko is a sushi, right? And so
Okay,
our team likes sushi. And so it's a flying fish egg sushi.
nice. I'll have to go try that. I don't think I've ever had that actually. Maybe I have, but cool. All right. Well, thanks, Sobi.
Thank you.
Yeah, good to chat with you. Take care.
All right.